This is about Newton's law of cooling. It states that the rate of change in the temperature of an object is proportional to the difference between the object's temperature and the temperature of the surrounding. Now, the problem that we have here is of the temperature of an object that is initially at 100 degrees Fahrenheit. The temperature of the room is kept at a constant temp, which is 60 degrees. So we want to know how long it takes the object to cool from 100 to 80 degrees. All right, you have this in your notes. Let's get to work. So what we write here is that by the Newton's law of cooling, says that the rate of change, which is dy dt, is proportional to the difference between the temperatures, the object's temperature and the temperature of the surrounding. So this means that this one will be y minus 60, 60 being the temperature of the room. So what we do is we remove this proportionality sign and write this as dy dt is equal to y minus 60. Okay. Next thing is to solve this differential equation. We separate the variables. Y minus 60 goes down there, dt goes there, like we've done before anyway. So dy y minus 60 is equal to k dt, and then integrate right there. So left side will be ln of y minus 60. Right side will be t k plus a constant. And now what we do is we use the definition of logs to rewrite this. I'll write this again. Ln y minus 60 is equal to t k plus c. This as log of y minus 60. Show the base is tk plus c. And now we raise e to that power, which means that y minus 60 is equal to e raised to that power, e t k plus c. These are constant. Separate the two to read y minus 60 is equal to e t k times e power c. This is a constant. You can call this capital C. And this will read y minus 60 is equal to c e tk. Now you can move this to the other side, and this will be 60 plus c e tk. So this is the formula that we're going to use. The temperature of the object is 100 degrees Fahrenheit initially. So initially means time is 0. Back to that equation there, we substitute two things. Y are 100 degrees for y and 0 for t. This is 60 plus y sub 0 e t k. So 100 is equal to 60 plus y sub 0 e. The time is 0 here, so this will be 0 k. So this means that this is 1, and we have 100 is equal to 60 plus y sub 0, meaning that y sub 0 is equal to 100 minus 60, which happens to be 40. So with this in mind, we change this equation to y is equal to 60 plus, that is 40 e t k. Now remember, the temperature falls from 100 to 90 degrees. So this is y is 90 degrees. after 10 minutes. We substitute this for y and 10 for t to get 90 is 60 plus 40 e are 10k. Now we subtract 60 to get 30 is 40 e 10k. Divide by 40 to get 3/4 is e 10k. Take ln of each side. This is ln 3/4 and this one will be 10k. Divide by 10. This implies that k is ln 3/4 over 10. And you can write this as a decimal number, negative 0.0287668. That will be enough. So we want to know when it cools to 80 degrees, how long does that take? So we substitute this constant back into this equation here. Y is equal to 60 plus 40 e. The constant is negative 0.028768. That's a constant, so we have t there. And we want to know when the temperature drops to 80. So we substitute 80 for y. So this is 80 equal to 60 plus 40 e negative 0.028768 t. So two things we need to do before we take ln. Subtract 60 from each side, we get 20 is equal to 40 e, this exponent, divide by 40 each side, and this will be 1/2 e. Take ln, and this one will be ln of 2 is equal to negative 0.028768 t. Divide each side by this decimal number to get t. These two negative signs cancels off in the meantime. So this will be ln 2 of 0.028768. And this one is 24. How much longer will it take for the temperature to decrease to 80 degrees? From 90 minutes? That's the answer, 24 minutes. Remember, it started from 100 to 90, and then from 90 to 80, it takes 24.